All right, we are going to analyze Unit 5 exam, similar shapes. The diagram shows a door that has a window in it. The front faces of the door and the window are similar rectangles that have the dimensions shown. What is h, the height of the window, in centimeters? Round to the nearest centimeter. All right, so we had to use our proportions, and I set up, this is the door, right? So I did the length, 200, over the 60 centimeters width. So I do not know my height, right? I don't know the height, so I put an h there, or an x there, I'm sorry. And then I put a 38 to my corresponding 60. Then I just cross multiplied, and you'll have to work those out, right? So 200 times 38 is 7,600, and 60 times x is 60x. So at this point, all I would have had is 7,600 equals 60x. Then I need to isolate my variable, and to do that, I need to divide by that coefficient in front of the x, and that's 60. So when I divide by 60, 60 divided by 60 is 1, I bring down my x. 7,600 divided by 60 is 126 point, a repeating 6 value. And it's said to round to the nearest centimeter, so I need to round that up because this is a 5 or larger, so that's going to become 127 centimeters. So you should have chosen A, 127 centimeters. Number 2, Jessica has a rectangular picture. The picture is similar to a rectangle that measures 10 inches by 14 inches. What could be the dimensions of Jessica's picture? So I've got the rectangle here, and it was 10 by 14, and we have her unknown picture. We don't know the dimensions. So first I took my rectangle I know, and I simplified 10 over 14 to 5 over 7. Once I simplified, it was really easy because that gave me the dimensions of the picture as an option. So number 2, you should have chosen C. 3, an architect built a scale model of a sports stadium using a scale in which 2 inches represents 30 feet. The height of the sports stadium is 180 feet. So I determined that 1 inch represents 15 feet, and so I used my unit right there. And then I needed to find out how many inches would be 180 feet. And so you could cross multiply and divide, but I was able to determine that 15 times 12 is 180. So then I just needed to multiply 1 times 12 to get my unknown inches, which is 12 inches. So 3 is B. 4, triangle ABC and triangle ADE are similar. Which equation must be true? So I've color-coded my sides to make this easier for me. So I have AD, which is the small upper side here, over AE, which is the small lower side. Then I'm looking at AC, which I would have wanted it to be AB for that. So this is flipped. So AD does not correspond to AC, so this is not true. B says BC, so BC, my large end, over DE. Okay, so I have big over little, that works. Then I have AD, which is the small triangle, so I'm flipping it again. That does not work. All right, I keep wanting to move that. All right, so AD over AB. So I have small, same corresponding side over big. So small over big, or little over big. And so I'm on this upper side. Now I'm at AE, which is small or little, over AC, which is the same side again, but the big. So that one works. Let's look at the last one and see why that one does not work. AC, so I have AC, that's the big one, over AB, which is so we have lower big over upper big. Then I have DE. Okay, that does not correspond. So AC does not correspond to DE, so that does not work. So for number 4, you should have chosen C. 5, Corbin made a scale model of the San Jacinto Monument. The monument has an actual height of 567 feet. Corbin's model uses a scale in which 1 inch represents 100 feet. What is the height in inches of Corbin's model? So I used my 1 over 100, 1 inch over 100 feet, to figure out my unknown inches over 567 feet. I cross multiplied, and I got right here, 567 times 1 is 567. 100 times x is 100x. Then I needed to isolate my variable to solve for x, which meant I had to divide by 100. 100 divided by 100 is 1. I bring down my x. 567 divided by 100 is 5.67. So the height in inches of Corbin's model is 5.67 inches. Number 6, quadrilateral ABCD is similar to quadrilateral WXYZ. So the first thing I did was remember the order that these go in shows me the corresponding angles. So A corresponds to W. So you can see my A and W, I coded them the same. B corresponds to X, B and X. This helps me determine how it's oriented so I can find the sides that correspond. So it says, which statement about these quadrilaterals must be true? BC over CD. So I have BC over CD. So I'm on the larger quadrilateral, and I'm on the lower to the left here, which is blue and green. Then I have ZY, which is over here. My BC does not correspond to ZY. Next, I have angle DAB is congruent to angle XYZ. And remember, if you're looking for the angle, you can just take that letter in the middle. So angle A is right here, DAB, so angle A, and then XYZ, XYZ. So those do not correspond. They would have been the same color. CD over AB, so I have CD over AB. So I'm on my green and blue and pink and blue. Then I have WX. WX, that is again the opposite. I should have seen green, blue, green, blue. So CD does not correspond to WX. Last one, angle ABC. ABC, right? So that's this pink one right here, is congruent to angle WXY. So where's X? Right here. And again, we have corresponding angles. D is the correct answer for that. Number 7, Anna drew a map of the Panama Canal. In the scale Anna used for the map, 5 centimeters represents 25 kilometers. The actual length of the Panama Canal is 87 kilometers. What is the length in centimeters of the Panama Canal on Anna's map? So 5 centimeters represents 25 kilometers, so 1 centimeter is going to represent 5 kilometers. I just simplified my scale. So I've used 1 centimeter over 5 kilometers is equal to unknown centimeters over 87 kilometers. I cross multiply. 1 times 87 is 87. 5 times x is 5x. And again, I need to solve for x, so I divide by 5, divide by 5. X is equal to, and I did my division right here, 17.4. 17.4 centimeters was the length in centimeters on Anna's map. Number 8, triangle ABC is similar to triangle ADE. So here again, I have a triangle inside of a triangle. And one thing that they've done here is they've given me the dimensions of my small one, it was 12. They haven't given me the dimensions of my large one. They've just told me what additional is added. So I've then just added 12 and 6 and said that my length of this leg AC is 18 inches. So first thing I looked at was my known base is 10 inches and my larger triangle has a larger base. So my X needs to be larger than 10. So I was able to knock out 5 inches and 7.2 inches. Those could not work. And then I was left with just 2. I went with big over little. So when I set my proportion up, I went with 18 over 12. 18 over 12 is equal to x over 10, which is big over little, big over little. Then I cross multiplied. 18 times 10 is 180. 12 times x is 12x. So at this point, we're just here. 180 equals 12x. And then to solve for x, I need to divide by 12 on both sides. 12 divided by 12 is 1. I bring down my x. 180 divided by 12, I've done right here, is 15. So the value of x is 15 inches. Number 9, Mr. Dieter was trying to prove that two triangles were similar. Which statements about the triangles must be true in order for them to be similar? So this is just knowing the rules about similar shapes, and that they need to have corresponding angles that are the same measurement or congruent, and they need to have corresponding sides that are proportional. They do not need to be the same size shapes, but the shapes themselves need to be the same. So let's look at this. They are the same size and shape. Okay, we don't need them to be the same size. They have corresponding sides that are proportional. Yes, we need them to have corresponding sides that are proportional. They are the same size but different shapes. No, they need to be the same shape. D, they have corresponding angles that are congruent. We do need that. So B and D were the correct responses there. Number 10, triangle ABC is similar to triangle DEF. What is the length in inches for X? All right, so again, I've color coded these, and I'm doing little over big, and it doesn't matter as long as you go little over big, which is what I did. I did little over big, 3 over 9, over 5 over we don't know. Then I cross multiplied. 3 times x is 3x. 9 times 5 is 45. So at that point, I'm trying to solve for x. Divide by 3 on both sides. I have x equals 15. So we have 15 inches as our length for x.